Good morning, students. Today we are going to discuss an important topic in engineering design, that is requirements in engineering design. Before starting the design of any machine, product, component or system, we must clearly understand what the product is expected to do. For example, suppose we are designing a water pump. We cannot simply start drawing the pump. First, we need to know what quantity of water should in what quantity of water should it pump, what pressure is required, what is the operating speed, what is the power available, what type of fluid will be handled, what is the expected service life, what are the size and weight limitations, and what is the allowable cost. All those are called design requirements. So we can say a design requirements describes what a product, component or system must achieve or satisfy. Then what is an engineering requirement? The engineering requirement is a clearly defined the needs or condition that the final product must satisfy. The requirement may describe function, performance, dimensions, material, safety, reliability, cost, manufacturing, environmental conditions, and finally maintain. Let us take a simple example. Imagine what we are designing a shaft for a gearbox. The requirements may be the shaft must transmit 5 kilowatt of power. The operating speed is 1000 rpm. The shaft should withstand the applied torque. The shaft should have sufficient fatigue strength. The shaft diameter should fit inside the available space. The material should be suitable for manufacturing. The cost should be economical. Notice that those requirements are different from the final dimension of the shaft. So, all the requirements tell us what the design must be accomplished. The design process then determines how to accomplish it. So, why are design requirements is important? Students, requirements are extremely important because they from the starting point of engineering design process. If the requirements are incorrect or incomplete, even a technically excellent design may fail. Consider a simple designing example for ceiling fan. If we only specify design a fan, the requirement is incompleted. When need additional information such as required air delivery, fan diameter, rotational speed, motor power, voltage, noise level, weight, safety requirements, operating environment, expected life and cost. Only after understanding those requirements we can able to design the ceiling fan. Therefore, we need clear requirements, better design, better performance, and less failures. What are the types of engineering requirements? Now let us discuss the major types of requirements. Functional requirements. You see that requirement for engineering design. First one is functional requirements. The product should do its job correctly. The product should do its job correctly. That is the functional requirement. Example, a fan should rotate and provide air. So, what is the function of the fan? It should rotate and provide air. That is the primary function of the fan. So, the function requirement describe what the product should do. For example, for a hydraulic jack, you take another example, that is a hydraulic jack. It should lift a specified load. So, hydraulic jack, maybe it should be lift and it should raise the load to the specified weight. There is a 200 kg or 300 kg or 500 kg. What should be the weight? That weight could be raise the load to the specified height. Then it should hold the load safely. This is the function, is the primary purpose of the product. That is the function requirement. Next one is performance requirement. Performance requirement specifically how well the product should be performed. How well the product should perform. For example, a motor may be required to produce 5 kilowatt power, 1440 rpm speed, specified torque, specified efficiency. So the function tells us what is does, while performance tells us how well it does it. Next one is physical or dimensional requirement. So specific the physical limitations for such example is length, width, height, diameter, weight, mounting dimension, available space. Based on this, we can go for dimensional requirement. For example, if a component has to fit inside a machine housing, its maximum dimensions became an important requirement. Next one is material requirement. The material must be selected according to the application. For example, for a shaft, we may require high strength, good fatigue resistance, good machinability, suitable hardness. For a lightweight structure, aluminum alloy may be preferred. For a high temperature component, a heat resistant material may be required. Therefore, the material selection is also influenced by design requirement. Next one is safety requirement. The safety is one of the most important requirement. A machine should not only perform its intended function, it must also operate safely. For example, moving parts may require the way. The electrical system require insulation and protection. The electrical system requires insulation. The pressure levels require appropriate safety provisions. The lifting equipment must withstand the required load safely. So the design that performs well but creates unacceptable safety risk is not a good engineering design. Next one is reliability and life requirements. The designer must also know how long the product is expected to operate. For example, the bearing may be required to operate continuously for a specified number of hours. So we give the bearing is operate up to continuously for 1,000 hours or 2,000 hours. We want to specify. Similarly, an automobile component may need to withstand millions of loading cycles. That is service life, reliability, fatigue life, and maintenance interval. That is very important. Another one is cost requirement. The cost is another important requirement. The designer must consider material cost, manufacturing cost, assembly cost, maintenance cost, and operating cost. Technically, excellent product may not be commercially successful if its cost is too high. That is the we think about cost also. The engineering design is usually balanced between performance and cost. That is the real requirement. Next, source of design requirements. Where do those requirements came from? There can be several sources. Customer. The customer may specify capacity, size, performance, cost, features, and standards and regulations. Engineering product may have to specify applicable standards, codes, and regulations. The existing product. A new design may developed based on the existing product. Manufacturing department. Manufacturing engineers may specify limitations related to machines, process, tolerances, materials, and production quantity. Environment. The operating condition also create requirements. For example, temperature, humidity, dust, corrosive atmosphere, and vibration. The operation condition also. Good engineering requirements. A good engineering requirement should be clear, specific, measurable. That is good engineering design. So, the requirement is something that a product or machine must have or must do work properly. That is the requirement. So, requirement of engineering design, that is nothing but function. The product should do its job correctly. For example, a fan should rotate and provide air. That is the function requirement. Second one is safety. The product should be safe to use. For example, we are riding the two-wheeler. A helmet should protect the head. Third one is strength. The product should not break under load. For example, a chair should support a person's weight. A chair should support person's weight. Third one is strength. The product should not break under load. Example, a chair should support a person's weight. Fourth one is reliability. The product should work for a long time without failure. Example, a motor should run smoothly. And fifth one, cost, low cost. The product should be making the product should be less cost to make and buy. Sixth one is easy to manufacture. The product should be easy to produce and it can be easy to manufacture. Easy to maintain. The product should be easy to repair and service. During service condition, we can use standard parts, so we can able to easily service the product. And good appearance. The product should look attractive. Then comfort. The product should be easy and comfortable to use. And finally, environment friendly. The product should create less pollution and save energy. These are the important 10 requirements for to create engineering design products. Students, remember this sequence. The requirement, that is, what is the need? First of all, you can understand what is the need, requirements, concept, design, analysis, prototype, testing, and final products. So, the requirements came very easily in the design process. If the requirement changes, the design may also need to change. For example, the requirement if the required load of the machine increases, we may need a larger shaft, larger bearings, high motor power, stronger structural members, and different materials. Therefore, requirements have a direct influence on engineering decisions. So, let us conclude today's class. The important points are requirements define what the engineering product must achieve. The requirement may include function, performance, dimensions, material, safety, reliability, environment, and cost. The clear requirements are essential for successful engineering design. The requirements should be clear, specific, measurable, and realistic. The designer uses those requirements to develop and evaluate the final design. So, always you remember that a good engineering design starts with a clear understanding of the requirements. Thank you, students. In the next class, we can continue with the next stage of engineering design process and see how those requirements are converted into design specifications and engineering concepts. Thank you, students.